Hello everyone, welcome to All About Solar, and the soul of all energy. So today we will learn the IV characteristics of solar power plant. It's a very important topic to understand how the solar power plant and solar panel generation can impact it through the solar irradiation. So before wasting any time, let's jump into the session. So here you can see that we have a Adani Solar panel, Eternal Pride. This is a new panel of that Adani Solar series. And here every solar panel datasheet, if you have look for any kind of solar panel datasheet, you'll find this IV curve. IV curve means, I am telling you, this is a basic degradation curve they have shown in their datasheet, but I am talking about here this IV curve. So this IV curve you can get from any datasheet, as well as through the PVC software, you can get this kind of IV curve as well. So here you can see this is basically the IV curve for this particular solar module, which is having a different wattage rating. So for this particular case, it is a 640 watt peak solar panel datasheet, and here this IV curve is applicable for a 640 watt peak solar module. Now, IV curve actually stands for VI characteristics of solar module. VI characteristics mean voltage and current variation with the variation in solar irradiation. And here the cell temperature will be constant, which is 25 degrees centigrade. That means the STC condition, the standard test condition, if the cell temperature of the solar module is 25 degrees centigrade, then with the certain solar irradiation value, how the generation you will get, that is the basic meaning of IV curve. What will be the voltage and what will be the current at different solar irradiation. So here you can see these are the lines. This is 200 watt per meter square, 400 watt per meter square, 600, 800 and 1000. So it starts with 200 and ends with 1000 watt per meter square, because in standard test condition the solar irradiation limit is 1000 watt per meter square. Now here you can see at different solar irradiation the power output become different. It meaning that when you have a minimum irradiation like 200 watt per meter square, at that irradiance, and when the temperature is 25 degrees centigrade, at this temperature and at this solar irradiation, the power output you can get, which is 128.12. How? Because in this particular condition, your voltage is, you can see that almost nearby 40, above than 40. Here this is the point, if I consider this point. So here you can understand that this is your VOC basically. And at this point, this is your VMP and this is your IMP. So IMP basically with this 200 watt per meter square, the IMP value is below than 0. That means the voltage is almost nearby constant. That means this point, which is nearby 38 or something nearby that voltage, you can also check the VMP here. So for 640, the VMP is 37.01. So that means this specific point, this point is 37.01 here, and this VMP will be stable. But at different solar irradiation, the current value will increase. That means when you have a 200 watt per meter square, the current below than 0. And when you have a 400 watt per meter square, the current can came like nearby 5 or 6 ampere. When you have a 600 watt per meter square, the current can came nearby like 12 ampere. And when it reached to 1000 watt per meter square, that means at this point you have a IMP and VMP already there. So IMP into VMP will be your PMP, or the maximum power, PMP. Here PMP is this basically this value, 640.64 watt peak. So this way we can understand that with the IV curve is basically, we are saying that it is VI characteristics of the module, but in this case mostly the VMP will be constant, but the change, the value which will change with the solar irradiation increase, that is the current. So when every time when you have the higher irradiation, the current will increase, and multiplication of this current value and VMP value, you will get the power rating. This is basically power at maximum point. Okay, so here if the IMP is maximum and VMP is maximum, then you will get the PMP at 1000 watt per meter square and at 25 degrees cell temperature as per the standard test condition. So if you want to know about the standard test condition and NOCT condition, I already have a video on it. So please check out the card. So that's all about the IV curve understanding. So if you like this video, follow us for more learning. If you are interested about the solar plant design, or if you want to know about the solar technology, solar panel technology, inverter technology, you want to learn the design, the softwares like PVC, AutoCAD, Helioscope, SketchUp. If you want to learn all those softwares, so you already have a course on this advanced solar design course. It's a long course, and after completion of this course, you will get a job placement opportunity as well. So if you have any interest in solar field, please check out the link below. I have already given the registration link, so please check out the link. And if you like this video, don't forget to like and subscribe to our channel. So that's all from my side. We'll catch you guys in the next video. Thank you for watching.